Hey, everybody. I think it's a good practice to look at good known signals before we go much farther and look at the signals with glitches. So this is going to be another part in our lab scope series. So let's get started. Alrighty, these are lab signals that I know are fairly good, or at least good enough to actually have a car running properly. But one of the things I would like to do is look at known good, and some of your scan tools, some of your lab scopes will actually have known good signals, and you can identify them a little bit easier that way too. But it's always good to look at the good stuff before you start looking at the bad. So this is it's kind of normal two-wire sensor, speed type sensor that, is easy to see that we got good waveform. There's really nothing to see in particular that is maybe that's not in good shape. But this has got I didn't put the whole scale in here, but this has got a peak to peak of about 3 volts. And then it has, a rise and fall, I should say a positive 1.5 and a negative 1.5. So this looks really, really good. So this is a good, if you're doing your speed sensors, like your ABS speed sensors, or maybe you're doing an old 2-wire crank or cam sensor like that too. Then your fuel injector sensors. This is a good pattern. This is a good one that I actually have seen. So I want to be clear that these are not just me bringing up all these different types of patterns. These were actually sent to me by friends, and I collect them. I have a whole lot more. I got collected of bad and good. If you have any, sensor signals that you'd like to send to me, please do. I'll put them in my library, and you'll probably be featured in one of my future, videos like that. So this is a good known, fuel injector signal that I've seen, and it, goes up to about 14 volts. When you start turning it on, of course, it's going to jump down because it's completing that circuit, and then you're going to get a spike. Okay, you're going to have something rise quite a bit high. Now, the other part I didn't show you is there's actually another signal, which I'll get into later on in a future video and like that. So the spike can actually go up to like 70 volts. So this is normally, you go up to about 14, but the spike, sometimes you really got to look at your scale when you start doing this. So this is actually spiking up to 70 volts right here. So if you look at the scale, you're getting quite up there. This is peak and hold, and these are, again, it could be a fuel injector. This is a peak and hold signal. So don't be thinking that all injector signals are the same. So they'll peak out and they'll go to a hold mode like that. So this is a little bit different. We'll get more into this when we start talking about injectors in the engine performance side of the videos as we go along. And this will hold, pretty much peak out at about 4 amps of current flow, when it first gets into it, and then it'll kind of hold on, as low as 0 volts. This is, mostly somewhere around, I would say 1 millisecond. It depends on how the injector is built. Let's put it that way. But this is a good signal. I don't want to get sidetracked, because again, I'll be putting in another video together all about fuel injection and the different signals will be added in there. This is a primary signal. You've probably all seen this, especially as old timers, when we used to have all the primaries and secondary signals on our scopes. And we would actually look at it and dissect it, and you can tell by every little section. Again, I'll be getting into more of this when we get into our ignition system as part of the engine performance. So, but this is a good signal. And then we have a Ford that actually, one of the V8s that have a 3-strike type of ignition system. This is, multi-strike type stuff that Ford uses, and depending on the mode is what it's going to actually, the pattern is going to look like. So this is a good example, and they also had the 3-strike ignition systems on their V6 engines also. Here we have a crankshaft signal. This is a good, almost like the one we had in one of our previous, I should say lectures. This is a good example of one right here. And we'll actually break this down even farther as we go into that ignition system part of our actual ignition system part of our engine performance classes. But this is, this actually has like a, almost looks like a normal, kind of a sine wave type signal. You actually see some interruption right here. We'll talk more about that as we go along, but this is a good example here too. And this, if you were actually seeing something like this on a wheel speed sensor, you would probably say, hey, I've got a tooth missing on this. Here's, just a square wave of kind of showing up to battery voltage, or it could be just you're getting a nice little square wave signal. All 3 wires sensors, which are, definitely going to be like your optical sensors, your different thick film sensors and stuff like that are going to be pretty much like this kind of a signal on them. And then we have a 2-wire, camshaft signal off of a Ford. This is a 3-volt peak to peak voltage on this one. And again, it's a 2-wire signal on a Ford. And then the idle air control on a Ford, the old style Ford, and I will be updating some of these slides too. I just want to show you different patterns that are actually good if you're actually measuring at these specific sensors and stuff like that. And then a Ford mass airflow. It was really, what's really kind of cool, I think, on this one is you can actually see when the air, the throttle is opened up. It changed the actual. So this was actually when they went into wide open throttle, you can actually see how airflow changed this signal. And you can do a lot with lab scopes. That's why I keep on saying you need to have a lab scope. This is a Toyota crank sensor signal. I think I showed you a slide similar to this before, and we can actually dissect this around. You can actually see as the speed changed. Now this is a 5-volt peak to peak on this particular one right here. And then we have a Toyota crank signal. This is going to be a square wave, and you'll notice it looks a little bit different. How we have this going on. This is how they place the teeth on it, and that changes that signal, telling it, hey, and we're getting ready to come up to top dead center. So it tells the position of the actual signal going on. This is a Mazda crank sensor. You can actually see nice, clean square waves on it. And this is why I'm showing you a lot of this. This is a 5-volt square wave. And the reason I show you this is because when you go into other crank sensors signals, you might see a little difference, and you don't want to condemn them until you know what a good one looks like. And here is a Mazda camshaft signal on this particular one right here. So this is a little bit different. You can see that's not exactly like the crank sensor that we had in the slide before. This is a Mitsubishi cam signal, a crankshaft crankshaft sensor signal, and this is one that actually looks pretty even all the way across the board. This is a 5-volt square wave on this particular, which actually changes with RPM. And then we have a Mitsubishi cam sensor signal, and you can see it almost looks like the Mazda one that we had before. And again, this is a 5-volt square wave. And then we get into our Jeeps. This is an actual 4-liter crank sensor signal on our Jeep. And you can see it's totally different than the signals I've been showing you just a few minutes ago. And we'll start breaking this down when we get into our engine performance ignition system section. And then here's the camshaft. So you can see it's a lot different than the crankshaft on this one, same vehicle. And then we go into a Jeep crankshaft sensor on a 2005. This is a little bit different. It's a 5-volt square wave again, but you can see the placement of the different peak and rises on it. I shouldn't say peak and rise, the square wave on it is a little bit different. We have a down turn, like it's turning on, turning off. And then a camshaft signal on a Jeep, it's the same 2005. So you can see it's different, and that's because of the placement of the teeth and all. And this makes it so that we can see where the position of the engine is at. The camshaft coming up at number 1, it may be just it actually is that I'm like that. So I kind of stumbled there a little bit. But anyways, this is what I have for you right now. This was a 5-volt tube. If you like this, please like and subscribe. My cat wants out right now. So take care, and I'll see you on the next video where we get more into lab skills. Bye for now.